In lesson 13, we're looking at substitution and area of an isosceles triangle. In the first example, we're going to use substitution to solve this system of equations. X equals y plus 5 and 3x plus 2y equals 5. So since the x is already by itself, we can replace the x down here with this y plus 5. So I'll have 3 times y plus 5 plus 2y equals 5. So now we'll have one equation with one variable, and we can find out what y equals. So we'll use the distributive property with the 3. We have 3y plus 15 plus 2y equals 5. Get our like terms together, so 5y plus 15 equals 5. And then we'll subtract the 15 to move that to the other side. So 5y equals negative 10. And then we'll just divide both sides by 5. So y equals a negative 2. Now, a lot of times you want to feel like you want to stop there, but we also have to find what the x is. So we need to take this negative 2 and replace a y with that. So we'll go over here and I'll have x equals negative 2 plus 5. So x equals 3. So the point where these lines intersect is 3, negative 2. And that's our solution for that system of equations. In the second example of the system of equations 3x minus y equals 11 and 2x plus 3y equals negative 11, we do not have a variable that's by itself. So what we'll need to do is get either the x or the y in one of the equations by itself so we can substitute that in for that variable in the other equation. So what I'm going to do is use this first equation here. 3x minus y equals 11. And I'm going to get the y by itself. So I'm going to subtract 3x, so negative y equals negative 3x plus 11. And then I need to get rid of the negative sign, so I'm just going to multiply everything by a negative 1. You could divide, and it'll still just change all their signs. So y equals a positive 3x minus 11. Okay, now I can replace the y in the other equation, this one right here, with this 3x minus 11. So we'll have 2x plus 3 times 3x minus 11 equals a negative 11. Okay, then I'll just solve this for the x, so I'll use the distributive property first. So I'll have 9x minus 33 equals negative 11. Then I'll get my like terms together, so that's 11x minus 33 equals negative 11. Then I'll add the 33 to move it to the other side, so that'll be a 22 equals 11x. Then I'll just divide both sides by 11 to get x by itself with a coefficient of 1. So x equals 2. Alright, now we know what x is, but we still need to find what y is. So we're going to replace the x here with the 2. So y equals 3 times 2 minus 11. So multiply those together. Y equals 6 minus 11. So y equals a negative 5. So the point where these two lines intersect is 2, negative 5. And that's our solution for this system of equations. Alright, our third example is another system of equations that we're going to use substitution to solve. And again, we don't have an x that's all by itself or a y, so we'll need to choose which one we want to get by itself, I think I'm just going to go ahead and use this first equation, x plus y equals 20, and I'm going to get the x by itself. So I'm going to subtract the y. So x equals negative y plus 20. Now I can put this in place of the x in the other equation. So I'll have 5 times negative y plus 20 plus 10y equals 150. Then I'll use the distributive property and multiply that 5 across. So it's negative 5y plus 100 plus 10y equals 150. Right? Then I'll get my like terms together. So I'll have 5y plus 100 equals 150. And I'll subtract the 100 to get the 5y by itself. So 5y equals 50. And I'll divide both sides by 5. So y equals 10. Okay, now I still need to find out what x is, so I'm going to put that 10 in place of the y up here. So x equals a negative 10 plus 20, so x equals 10. Alright, so where these two lines intersect is at 10, 10. And we solve our system of equations. Alright, our fourth example is to find the area of this triangle that we're given. Now notice that this is not a right triangle, so we are going to have to actually find what the height is here. We do not know what this height is, so what we're going to do is split this in half, so that would make this side 2 and that side 2 as far as the length goes. But we're trying to find this. We're going to pretend like that's really a straight line and makes a 90-degree angle. And we'll just say that this side is A. So we're going to find this height by using the Pythagorean theorem. So I have 2 squared plus a squared equals 5 squared. We'll go ahead and square, oh I said 5 squared, not 52, equals 5 squared. There we go. So I'll have 4 plus a squared equals 25. Then we'll subtract the 4 to move it to the other side. So a squared equals 22. And then take the square root of both sides. A equals the square root of 22. Now this does not simplify, so we are just going to leave that as a square root. And we know that the area of a triangle equals 1/2 of the base times the height. Alright, so our height is that square root of 22, so we're going to fill that in here. The base is 4, so we'll fill that in for B. So the area equals 1/2 4 times the square root of 22. Alright, then we'll multiply this together. So the area is 2 square roots of 22, and this is in centimeters, so it's going to be centimeters squared. And that's the area of our triangle.